you can actually put an algorithm together that describes those processes. So the behaviourists say, yeah, there's really no problem with modelling human beings. So, okay, so assume we've hand-modelled human beings, so how do we then go about actually observing what they do? So as scientists, how do we actually interpret what they do? There's two ways in which we do that, which is inductive reasoning and inductive reasoning. And if you've done a science degree, you might have sort of come across these things. So just looking at inductive reasoning here, it's based on observation. So we go out and look at things and see what's happening. And it's basically the inference of general principles from specific rules. So if we have these three boxes here, we have a blue triangle in the corner, second one, next corner. So we can infer what's next, right? Everyone would have sort of made the steps and thought that's where the was going to end up. Whereas in deductive reasoning, it's basically based on interpretation. It's inference of specific facts from general rules. So these are two examples of deductive reasoning. All men are mortal, which is just a fact, or a general rule. Socrates was a man, therefore Socrates is mortal. That's basically how deductive reasoning works. Same with the ape. Apes like bananas, this is an ape, and it speaks for itself. So when we look at those two ways of reasoning, we can say, oops, this is a causal black box. We sort of don't know what the cause is. So if you look at agent-based models, then we can say they're empirical heuristic-based agents, so it's based on observation. Whereas the deductive reasoning side here is basically a cognitive white box. We don't really know what goes on in the head. The cognitive box, as I call it, is what goes on in the head. So in an agent-based context, you would have formal logic compliant agents. Now we use a bit of both in the way we do science, but it's important to remember that fact that there's different ways of looking at the world and observing the world. So just a little bit about the cognitive box, what goes on. Do we need to actually know what goes on in the head when we're trying to model people? Well, ask an economist. Sorry, Rashid, but I'm going to make some generalisations here. What do economists do? Well, they're faced with a problem, there's some uncertainty, the rational agent gathers all the necessary information to make a judgment, and he makes a decision. So this is what is called homo economicus. And this is, of course, a generalisation. But the economists assume the person acts rationally, in complete knowledge of all the information, out of self-interest, with the desire for wealth. So this is the sort of basic principle of economics. So economists in the past have said, well, you can't really gain that much knowing about the way people make decisions by looking on what goes on in the head, because this is the way they make decisions. People don't really need to know what goes on in the head. However, psychologists obviously do need to know what goes on there. That's their bread and butter. So when these two gentlemen here are the most famous, I guess, for the economists, they're the most famous sort of psychologists. They're basically saying that if people are faced with a complicated task or a judgment, then they basically don't do that rational path at all. They make decisions on shortcuts, which they call heuristics or rules of thumb, basically. They take a shortcut. They don't gather all the information that's necessary. They take a shortcut. So these rules or these shortcuts, they basically explain how people make decisions, come to judgments and deal with problems. So these rules can be either learned or they can be hard-coded through genetic processes. So there's some bits in cross-fertilisation between economics and psychology. And basically, and Rashid yesterday talked about environmental economics being a subgroup of economists who had concern for the environment and thought economics is not dealing with these problems. Obviously, we need to do something a bit different. Whereas behavioural economics says, okay, we need to actually incorporate some of the knowledge from psychology into economics. We need to actually study the effects of, behavioural economics is basically concerned with the bounds of the rationality of these economic agents. So basically the behavioural economics is the study of the effects of the social, the cognitive and emotional factors on economic decisions and resource allocation. So it's just an illustration that economics is not just economics, there's other paths that people follow and other studies that have been incorporated in it. So just a bit more about the heuristics. So there's these rules of thumb that the psychologists usually know about that lead to some outcomes in terms of decision making. But the behavioural rules in psychology, they work well under most circumstances. But in certain cases, they lead to systematic error, or what they call cognitive biases. And I just want to spend a little bit of time on some of these cognitive biases, and I'll come to the context why it matters in the context of climate change. So you would generally find 4 groups of cognitive biases, and the first one is there's biases in the way we make decisions and show behaviour. So one famous one is loss aversion, or the endowment effect. So people demand much more from giving something up than they're willing to pay to get it. So basically, losing $100 affects your happiness much more than gaining $100. And it was already mentioned in one of the other past talks. So the next cognitive bias is in relation to probabilities and beliefs. And an example of one of those, there's about 50 of these ones. I'm just giving you an example to give you a taste of what they are. So there's such a thing as outcome bias, which basically means that people overestimate the probabilities, small probabilities, and underestimate large probabilities. And just as an example out of health, that low frequency events such as smallpox and poisoning and botulism are overestimated by a factor of 10 by people, and high frequency events like cancer and stroke are underestimated. And this is a consistent outcome in terms of behaviour. So then there's some social biases, and one example of a social bias is false consensus bias. And it's basically people tend to overestimate the degree to which others agree with them. So we all think that we're right, basically. And then there's my memory bias, and people often incorrectly think that past attitudes they had are the same as what they have now, and they didn't change over time. So these are just some examples of the cognitive biases. And these are, how do we actually know that these cognitive biases happen? Well, like biologists, psychologists do experiments. They do experiments with people to establish these predictable outcomes that are not quite what we expect. So one example of establishing one of those biases is called anchoring. And this is a really important one for the social sciences, and I'll explain why that is the case after I show you the example. But basically people tend to rely really heavily on an anchor or one trait in a piece of information when they make a decision. So they focus on one thing. So just to establish that, they did an experiment with 2 groups of students, and the question the students were asked was, guess the percentage of African nations that are members of the United Nations. So there was 2 groups, and the first group, the follow-up prompt was it more than 10% or less than 10%? And the second group was asked, was it more than or less than 65%? So what turns out is that, on average, the people in the first group that were prompted with a low amount said 25% on average. The second group, who was prompted with a high amount, which was the anchor, said it was 45% on average. Now this is a really consistent outcome in these experiments that the psychologists do. And even if the number that people are prompted with, the anchor they're given, is not, it doesn't have to do anything with the actual question, and I'll give you an example of that. So there's another example, another experiment they did where they got people to write down the last 2 numbers of their social security code, which it doesn't have to be a social security, but it could be the last 2 numbers of your bank account, for instance. So then they had 2 groups of people. So they had the people with higher numbers, so like 85, and they had a group of people with the lower numbers, so for instance 20. So they were asked to write this down before they did the experiment, and then they were asked to consider whether they would pay the amount that they wrote down, which is the amount that the bank account number, for something that they didn't know the value of, like a wine or something else. As it turns out, that the people who had the higher bank account numbers or the higher social security numbers were willing to pay 60 to 120% more for the product than the people with below. So they were anchored to their own last 2 digits of their social security number, which you would say is quite irrational. But this experiment's been repeated over and over and over again. So that anchoring, that bias, really exists. Now that's really important for social science because we go out and interview people and we do experiments, or not experiments, we do surveys where we try and establish, for instance, the value of a wetland, which doesn't have a tradable value, but people have to estimate, for instance, what they're willing to pay for conserving the wetland. So if we give them a survey and said, we're willing to pay $100 or $1,000, they will anchor to the amount of money that we prompt them with. So if your final value or your estimate of your wetland can be really biased by the fact that people anchor to the amount that you told them. So you have to be really careful of that in social science. So some of these willingness to pay surveys that people have done have vastly different values for instance, wetlands or other biodiversity aspects. So why do we care? Why do we care about these cognitive biases? Well, I just told you one that we care about because of the way it affects survey work, but Raghu mentioned in his talk that we care because, for instance, we want to know about how it affects climate change and communication. So things like, there's this thing called confirmation bias, which basically describes how people are more likely to search for the information that supports their preconceived ideas. And that matters because they did this experiment where they looked at the search terms that people used to look for climate change information. So the believers, they'll search for words like climate change proof, whereas the skeptics will look for words that basically look at climate change myths. So they're actually confirming their own preconceived ideas, and this was, I didn't actually get the reference here, but this is a well-known phenomenon. So you not only do you look for information that confirms your own ideas, but you also believe that everyone else believes the same as you, which is called false consensus bias, which basically means we overestimate the prevalence of our own opinion in society while we underestimate the things that conflict with what we think. So for instance, there was a survey done in Australia, a climate change survey, and it showed that 7% of Australians believe that climate change isn't happening. So that same 7% of people, they believe that 48% of people think it's the same as them. So this is an example of a false consensus bias. In fact, 78% of people believe that climate change is real, and 63%, this is Australian data of course, 63% that it's already think that it's already happening.
But doesn't it also depend in such questionnaires or polls how you ask the question and what exactly you ask?
Absolutely, yes, and that is another bias that you can create in your, like the anchoring effect, you can create a bias by the words you use, or there's all sorts of things that you have to be careful of when you do surveys. Yeah. There's a whole list of things that social scientists have to be careful of when you do surveys. So yes, absolutely.
In Australia, it probably depends on where you ask them before they drink or after.
There is a before?
Well, there's a high correlation between beer sales and El Nino.
Okay, so these biases actually tell us something about, for instance, how we deal with climate change. So some of the biases that I've read that climate change skeptics accuse the believers of, usually it's the other way around, we know that the believers accuse the skeptics of, but the skeptics also accuse the believers of some cognitive biases. So they say that basically the believers are overconfident in the predictions of their own models. They say that the believers think that the human reduction in climate change will make a large enough contribution to reduce global warming. And the skeptics think this is an illusion. There's this thing called loss aversion. The skeptics claim that the believers overestimate the cost of warming compared to the benefits, which is another cognitive bias. There's the bandwagon effect, which is the tendency of the believers to believe that change is happening because all their peers availability bias, that because the believers think of X,